Hello everyone. In the last two recordings, we converted the pseudocode that we had for random search for knapsack problem to a Python code, and then we studied the code line by line and we saw that it actually operates properly for small instances and produced expected results for our problem. Now that we are sure that our code is effective for small instances, it's time to increase the dimension of the problem. So we can increase the number of items. For example, we had 5, and so we are going to increase it, let's say, to 15 and see how our code behave. So before that, if you remember from the first one, we fixed the seed, so to actually isolate the randomness from our problem, and we did that to make sure that all the time that we run this code, the sequence of random generated numbers are going to be the same. So we are sure that everyone, for example, our first solution is this, and so therefore the feasibility is going to be the same. The value of the objective function also going to be the same. So we can again and again see how our model behaves, and we make sure that we are just focusing on one solution because we actually fixed that seed. So from now on, because we are sure that our code is proper for our problem, so we can just get rid of this line, or simply we can just get rid of this number. So from now on, when we run this code, there is no guarantee that the first solution is going to be 2 1 and then 3 zeros. So we run this line of code again, and we see that, okay, the first solution this time is 101 2 zeros. And so if I run this line of code again, we expect that this is going to be another solution. So let me run this line, and as you can see, we have another solution as the first solution. So this is one thing that we need to do after making sure that our code is good. And then what we can do is to increase the dimension of the problem. So let's say we have 15 items, so we have this new W and new V, and I set the capacity to be 20. So I'm going to just copy paste these 3 lines of code in here, and now we have 15 items. And so let's run this line of code, and here we go. So the line, so this is a good actually thing that we have here. So the first solution is this one, and the solution is infeasible. The next one is also infeasible. The next one is also infeasible. So all of them are infeasible solutions. Therefore, the best solution is none, and the best value is 0. So we know that this is not the solution that we are looking for. Maybe the reason is that the number of maximum trials. So we just allow our code to do that iteration for 5 times. So the next thing that we need to do, especially when the dimension of the problem is large, like what we have right now, so we should allow our code to do more, to generate more random solutions, so eventually get a feasible solution in our case right now, and then by increasing that number, so we can make sure that the solution that we have eventually is the closest one to the optimum solution. We know that with having a random search, there is no guarantee that our solution is going to be the optimum solution. So let's increase the number of maximum trials to 10 and run the code again. And here we go. So again, we have some infeasible solutions. Here we have our first feasible solution. So, and this is the best current, and the objective value is 32. And then we have our second feasible solution here, which improved the objective function from 32 to 40, and therefore this is our best value. So remember this number. So we had 32 and then we had 40. What we are going to do is going to increase the maximum trial, this time to 15, and see how our code behaves. Here we go. This time we have again one feasible solution. This is 32, and there is no other feasible solution. So our best value is 32. So you see, even increasing the max trial doesn't guarantee that we are going to end up in a better solution. But in general, when we increase them, let's say now we are going to have 20 and see how this code behave. So again, we have 31 and 33. And we also had 26. So this time we had three feasible solutions, but the maximum value is 33, which is less than the 40 I think that we had from the previous one. So let me do something. I'm going to fix the seed here again to 13 and do the problem with 10 trials or 10 iterations. So doing this, we are now have one feasible solution and the objective function is 29. Why I did fixed seed here? Because again, we wanted to show you if we are going to study how the maximum trials is going to affect our final solution. If we want to study this one, we have to make sure that again we isolated the randomness. So we fix this one and we gradually going to increase the max trials, so we see how increasing that value, that parameter in our model or in our code can affect the final solution. So we had 10, we had 29. I'm going to increase the maximum trial to 20 and see what are the solutions. So this time we had 29. Again, because we have fixed seed, so we always going to have this 29 again. And then we had 34 here, and here we have 41. So we can improve the final solution when we increase the number of trials, and the fixed is also, sorry, the seed is also fixed. So we had 20, let's increase this one to 30 trials. And if we do that, again, we have 29, we had 34, 41 from the previous one, and we don't have any other optimum solution in the next 10 iterations because all of them are infeasible. And let me, for the last time, I'm going to increase this one to 50 and see the solution. So all of them are again infeasible. We had some feasible solutions here, but because their objective function wasn't better than 41, so we didn't actually updated the best solution or the best value. And let me do one thing. So as you can see here, to make it a little bit better, I'm going to get rid of this one. I'm going to comment this line of code and also this line of code to do not print them all the time. And so yeah, and we had the 50. Let's make it to, for the last time, to 100 and see what is the thing. So why we have all of them here? So, oh yes, this is the one. And this one also, I don't want this one. And here we go. So yeah, now this is better. I don't actually want to print X. And so we have this line of code we are evaluating, and we have no printing till the best one. Okay, now let's run this code. And again, after 100 iterations, still 41. And let me do this one more time, make it 200 if it could improve it. So there is no improvement. So maybe this 41 is our optimum solution, because now we allow the model, the code, to iterate 200 times for this problem, and we still have 41. Maybe this 41 is our optimal solution. But the point here is that when we have, so first of all, the run the code for larger instances when n is, for example, is equal to 15, and we see that how increasing the maximum trial could affect the final solution. So we started from when we had 5, for example. If you have 5, if you remember, we had 29. So, and we finally stop in 41. So we could improve the number, the final solution or the best solution by increasing the number of iterations or the max trials parameter. And we also see how this seed could affect the problem. So let's play a little more game here. So if you remember, so we are going to see that. So when the maximum trial was 5, so we fixed the seed to 13, and for 5 iterations we had 29, and for 200 iterations we also had 41 as the best solution. So now that we see the effect of the maximum trial, I'm going to unfix the seed, the random seed, and see how this is going to affect, or I'm going to change the seed to something else. Let's say instead of 13 we are going to have I don't know, 24, okay, and see what will be the solution. So again, for 5 iterations it's still 29. Let's see if we have 200 iterations, what is the, okay, so for 200 iterations this time the best solution is 40. So it's still not the best as what we had so far, which was 41. And let's change the seed to maybe 33 and solve it with 200. So now this is a better solution. I change the seed to something else, 33, and for the maximum trial 200, the best solution is 43. So which is the best solution that we had so far. Okay, so which means that 41, as I told you, may probably be the optimal solution. Now it shows us that no, that wasn't the optimal solution, and we actually have something better here. So here is the thing. So to summarize it, so first of all, when we are sure that our code behaves properly and everything is as we expected, so we can unfix the seed and start having random numbers through every run of the code. And we also can try to implement the code on larger instances. Here we had 15 items, and also see how increasing the max trials or the number of iterations could affect our output. So here we saw that when we increase the maximum trials, so we can eventually have a better solution. We moved from 29 to eventually to 43 for this specific problem. So with that, I'm going to conclude this recording. Hope you enjoy it.